and then you find all the orders where chocolate is part of this order, who sold these orders, which other orders were sold by this employee, which other products were in there, so kind of a cross-sell, which products were sold together with chocolate, for instance, right? So then you can do something about it. So you kind of look at the other product and count how often it was sold with chocolate by a certain employee. So you know who's actually good at selling, I don't know, chocolate with cherries or something. Okay. To show you the stuff quickly in action, I have to. So this is Neo4j running in the background with its UI, and I just add some data to it. So this is the usual movie graph of actors and directors in movies. And now when I want to run queries on that, what I just do, I find patterns. So for instance, I can say match P person where name is Tom Hanks. And then I just return P, and this should be one person, Tom Hanks. And if I want to, I can kind of find his movie so like this, but I can also express this as a graph pattern and say where he acted in the movie. And then I run this and then get the same stuff. And then I can say, okay, I want to see for Tom actually all movies as aggregation, kind of his filmography. And if I look at the row thing, then I see Tom Hanks here. I can actually return his name. And all his movies. And of course, if I don't want this just for Tom, but for all actors, then I just say, give me this for all actors. And then I can also, of course, count how many movies are there. And give me the top 5 actors. Something like this. And for instance, if I want to only see actors who have more than 5 movies, I would kind of change this return into a div. Have to give them some names. So Tom, or the actor name as name, the movie title as movies, collection of movie title as movies, and the count as C, and then just say where C greater than 5. And I can do the ordering either past filtering or pre-filtering. If I do it past filtering, I have to order less. But I could also say I move this order by here, and but I leave it there. And so, or I have to return stuff, of course. So, and these are my 2 top actors, because it's not actually 5, but just 2 that make the top list. And you see that's already a pretty complex thing. What I can also do here is to say also where p.name or where p.name starts with T or something like that, and then p starts with domains. So so you see you can pretty quickly express complex stuff, and that's not all. I can also say, okay, instead of just seeing the movies, I want to see the directors as well, and then I would not miss the comma, and then I also see the directors and of all the movies, and it might be that there are some duplicates. Then if there are some duplicates, then I can just yes. So as I will soon talk about implementation, I just want to show you that actually you can access the query plans in Cypher here. So this is a pretty simple one. So you see it looks over the whole graph to find this node, and then filters, expands twice actually, projects, that's the width, then it does an aggregation as part of the width, then it does another projection, then it does the filter for the size, and then it does the top n and returns the results. And there should be also a sort somewhere, or the top thing is an top case select. So you can see the kind of the explained query plan, but you can also run profile, and when you run profile, then it actually also shows you how much database access it has. So this is actually a pretty simple query plan. I have some more advanced ones. I don't know. Oh, no, I just couldn't find the code. So the query that I mentioned before, the 200-line query actually creates a query plan that you can turn into a poster. So I told these people that wrote this that they actually should decorate their office with their query plans as a kind of nice touch. So it gets pretty complicated. So, yeah?
How are you approaching query optimization?
I'll talk about it in a second.
Awesome.
And it's also just, we've started with query optimizations, but we're not at the end of it, so it's, there's still a lot of stuff to do. For some simpler queries, we also support already bytecode compilation, so then the Cypher query is actually not interpreted like this one is, but it's actually compiled to Java bytecode and then run and optimized by the JVM as an optimized operation. Okay, so so what you see here as well is kind of the total database hits and how long it ran, which is probably way too long. And for instance, if I do an index on person name, then and I rerun this query again, it's not an oh, it's still because it's too much little data in database. Let me just add some more data. So, and if you run this again, yeah, then it's a node index seek. Oh, it's actually node index seek by range because the start thing is using index as well. All right. So much for this demo. Implementation of Cypher, we started quite a while ago. I think it was 3 years ago to start with Cypher. First one was only read-only queries. It used a really primitive query planner, kind of just went from left to right through the query and added operations to that. Then we added it to our server API, added collection functions, and so on. In Neo4j 1.8, which was 2 years ago, I think, we added write operations. Or 2.5 years ago, we added write operations, which brought an interesting part to it because then you have to kind of control the visibility of changes. Because if you match against something and you create at the same time, you have to watch out that you don't kind of leak your create operation into the match and then you kind of get to the endless things. So it had to add some eagerness stuff, which is sometimes a bit annoying. Then in 1.9 we added profiling, execution plan visualizations, and also made sure that we are always lazy as much as possible. So Cypher is only pulling stuff from the graph while it's returning data, and the only thing that causes it to be non-lazy is ordering and aggregation, actually. But otherwise, it's only lazy. So in Neo4j 2.0, there was a big change. We added this label concept to the property graph model, which also came up in Cypher, and then you could add like things like the option schema stuff, and added also new merge keyword, the up kind of the get or create things, little maps, and we added a new parser which was based on parboiled, not parser combinators in Scala anymore. An optional match, which is kind of an outer join, so you kind of match for a pattern. Usually, if it doesn't find a pattern, you get no results, and in an optional match, kind of the not found results would be set with null. So you can kind of get still something back, but you see what it didn't find. Then to one, we added load CSV, the data input stuff, and a new planner, a cost-based planner, so you combine, compute database statistics and use these statistics to start optimizing query in a better way. And we added unwind in a steakhouse, actually. And then in 2.2, cost planner became default. And there was also a new cost planner, not the original one, which performed much better. And in 2.3, I forgot to put in what we added in 2.3. We added also some stuff in 2.3. The text stuff, exactly. So it starts with and contains. So it's pretty easy to try it out. Just get Neo4j and you can try it. And you can use it in the embedded Java API via HTTP and also in the future via our binary protocol, JS3. And it's pretty simple across all languages. So Chris works on the PHP driver, but we also have drivers for .NET, Java, JavaScript, for C, C++, and so on. And it's a bit more efficient as well. How does it work? Today we pass the query, of course, into an AST. Then we normalize and optimize the AST. We do a kind of constant following. We also compute already expressions that we can compute. We rewrite the query in some parts. So for instance, the inline property syntax is actually rewritten into a predicate. And we rewrite some other stuff as well. We do some semantic checking as well as stuff that the parser couldn't catch. For instance, like type system stuff is done in this phase, and so on. So that's kind of the normalization of the AST, and then you create a query graph. It's kind of a high-level description of this query, and then we throw it at the optimizer to create a logical plan and compute the cost for the different plans. And right now it uses an IDP, dynamic programming optimizer. We used to do a greedy optimizer before, which had the problem that it ran into local minima, and then you had kind of suboptimal query plans, and this is much more exhaustive in terms of planning the query. So it kind of creates a logical query plan, and then we create a physical execution plan, which kind of turns this query plan into actual operators that execute on the database. And then we run it. And this whole stuff could be expensive in some cases. That's why we also cache the string to logical plan and logical plan to physical plan thing. So next time you come around, it's very fast. So it looks like this in pictures. And yeah, since 2.2 we're using by default the cost-based optimizer with database statistics. So we kind of, while the database is transactionally adding data, we also transactionally update the statistics of database, like degrees of nodes, degrees by type and direction, selectivity of properties, selectivities of indexes, and stuff like that. It's kind of tricky to kind of tune this cost-based stuff because oftentimes some kind of small changes have a big impact, and perhaps at some point we don't have to do it anymore if I trust Frank. No. Yeah, so currently in 2.2 it's used for read operations, and in 3.0 it will also be used for write operations. And something I didn't show you in the visual in the demo was if you have some stuff in the query that makes it not optimal, you get this kind of little yellow warning sign on the side of your query, and if you click on it, it says you're actually creating a Cartesian product, or you kind of filtering on a node where there's no index, or you have a typo in your query because you use a label or a property that actually doesn't exist in the database. And so that's actually pretty helpful, especially for people getting started. So query plans, we already saw them. Okay, so much as what we have right now. And we started in October to launch this Opencypher project, which should turn, so the goal is to turn Cypher into an open graph query language. So meaning, right now Cypher has been developed and implemented only by Neo. And with Opencypher we want to kind of make it open and kind of hand it over to everyone to use, to implement, to do whatever. So, and why do we do that? Because we love Cypher and our users love Cypher, and actually we just want to make everyone happy. That's the end goal anyway. And we want to allow everyone to, or enable everyone to run Cypher on their own data, on their own databases, and so on. So that's actually pretty cool. And Cypher is actually something that I should have put in. Cypher is actually not just good for graph data querying and updates. It's also good for it's also good for expressing other things. So for instance, Chris created a graph data generator that uses Cypher with a slide extension to represent data models that you can use to generate test data for your graph databases. Or Martin used Cypher variant to express test scenarios. So you can kind of express kind of assertions on graphs with syntax like that. And also in graphing, there's also similar framework that uses Cypher patterns to test against something like that. And we actually want to collaborate much more with everyone to create a really cool query language. So there's many things like, for instance, subgraph stuff that Martin added, which are really, really interesting. So, and why do people love it? Because it's pretty easy to write, easy to understand. Some people say it's easier to write in English, which might be not true or not. So it's actually pretty nice. Okay, so what's the idea behind it? We want to decouple the language from Neo4j. So kind of we pull out the stuff that we have right now in Neo4j as the open source project and pull it into a separate project, into the Opencypher project. We want to open the kind of whole language development process, make it more transparent, more inclusive, and encourage creation of new tools like testers, like generators, like highlighters, databases that implement it, and so on. And what we want to do is we want to provide language documentation, tools and implementation, reference implementation for Cypher. And the whole thing should be gathered by Cypher language group. So we thought about kind of giving it to an international standards organization, but that would probably kill the language, and that's why we kind of didn't want to do that. And so what do we have? Something that we already have is the CIP, Cypher Improvement Proposal. So if someone has an idea on how to improve Cypher as a language, you can just send a pull request to this repository that contains some kind of consistent stuff. And you can also submit feature requests when you have an idea, but you don't have a kind of formal thing around, just an itch or hunch what you want to do. And there's already a number of accepted CIPs. There's also templates and information about the contribution process. And this CIP looks like this. So we have some, so it's all in ASCII doc. So it's kind of textual markup, pretty nice to read and render and write. So motivation background. So why do I want to have this change? What do I want to achieve by that? The actual proposal with syntax and semantics. Alternatives, what exists already out there that kind of is similar or different from that. What does happen with the existing language? Is it affected by that or not, or the implementations? And what's really cool about this proposal and what's actually not so cool about this proposal. Right. And here's an example of the starts with so the text-based support CIP. So it's pretty straightforward, and things like, for instance, the subgraph stuff could be easily end up in something. So we have a stream. Yeah, I just told faster. So we have already some deliverables that we did, and some that we still have outstanding. So one is kind of this self-improvement process that I just showed you today. The governing body is also existing, and actually, as of today, we released the first EBNF grammar for Cypher, so that's really cool. So you're the first that hear about it, because it was just pushed to the GitHub repository 2 hours ago or something like that. So this grammar enables people to write, for instance, highlighters or verifiers for the language. It allows you to do query generation and validation and so on. Other things that we want to do is TCK for Cypher, so you can validate implementations. We want to provide a reference documentation and a full language spec. And we also want to provide a reference implementation under Apache license. Plus Cypher side guides, and also opening up at some point the language group, of course. So for the language spec, we already have now the BNF grammar and want to add all the other things that you know from SQL, from Postgres, for instance. They have a really nice documentation here. Semantic specification, especially also type systems and other things, and that should be all Creative Commons. The EBNF that was released today, here's a quick cutout of that. This is kind of match, unwind, merge, and there's much more before and after that, and you can find it in the GitHub repository. Yeah. So I'm really excited about this because now people can really start building cool tools. For instance, there's a guy in Lithuania, I think, who wrote a JetBrains IntelliJ plugin for Cypher editing and highlighting and so on. And he wrote his own eBNF, and now he can use just this one. TCK validates implementations, and it should kind of certify that it complies with a certain version of Cypher. And based on certain data sets, execute queries, compare results, and see that they provide you with style guide. You already predefined a style guide, which kind of explain what we think the expressions in the language should look like. But then there should be much more in the reference documentation, including tutorials and GraphGIS with lots of examples. So some examples from the style guide are what labels should be spelled like, relationship types, properties, and so on. Then which direction patterns should be directed, and for instance putting anchor nodes first, and there's much more stuff in the style guide as well. So this is pretty far already, and will be also released soon. The reference implementation is not as far yet as we want it to be, but it's something that we want to release as Apache license, so everyone can use it, do whatever, and so it's kind of split up into different parts: a parser turning Cypher into an AST, and then a query planner and a query runtime as well. And that can be either used as an example to learn about it or as base or foundation for implementation. So back in the days when Cypher was still based on the Neo4j Java API, I also wrote kind of implementations that run Cypher on object graphs or on file systems and stuff like that, just for fun. And something like this you can then also do with this reference implementation. Just put it onto something and run it, and then you can suddenly query your heap or something like that. Right? So Cypher Language Group is kind of a steering committee and the caretakers of the language, and they want to kind of make sure that this kind of these guiding principles, for instance, making the common things easy and the other things possible, that it always stays a humane language and it's focused on readability and so on. And actually, sometimes I was a bit frustrated with this here, I have to say, because I want to get in cool stuff, and then they tell me, did you actually really think about the long-term effects of your kind of proposal and what will it do to the language and so on? And then I had some, I had to withdraw some of my suggestions actually. But actually, it's good that they kind of focus on the kind of longer-term goals, and so the quick fixes and hacks will not end up in the language, which is actually good. And they also publish their meeting minutes and results, so you'll find them also on the website as well. Some people like it and want to support it, and so that's really nice. And some people that actually want to support Opencypher, and hopefully it will be many more. And so if you are representing an open source project, an organization or anything, and you think that's a good idea, then let us know, and we happily add you to the list and work with you on a really close basis. And you find all the stuff on GitHub and online, and there's also a Google group, and you're welcome to join the process and build a really cool GraphQL language. Thank you. After, just that I don't forget it, we have after FOSDEM a smallish table reserve right now with 50, I think. 50, right? So if you still want to join, come by, then let me know, and we will try to fit you in. And yeah, please contribute, and if you have any questions, we have a few more minutes actually, except if my phone. Any questions from